Hello. Today we will start a new topic. It is called EROI. We will talk about definition, history, and future implications of EROI. I think it is the most important topic in this subject, and you will see why. So at the end of this lecture, you will be able to define first and second law of thermodynamics. And you will be able to give examples about these two laws. You will define EROI, and we will discuss some examples. And after the examples, you may find some applications of EROI in your life. So let's get started from the energy and environment. So everything needs energy. Your body needs energy. That's why you eat, right? Or that's why you rest, why you sleep. Plants need energy. Animals need energy. Cities need energy. We need energy. We run on energy. We cannot do anything without energy. And there are laws that regulate this energy. These are called laws of thermodynamics. They do not regulate, but they help us to understand the environment and energy. So these are described the relationship between thermal energy or heat and other forms of energy and how energy affects the matter. When we say other forms of energy, it can be a light energy, mechanical energy, chemical, kinetic, potential, all sort of energies that you can think of. The first law of thermodynamics says energy may be transformed from one type to another, but is never created or destroyed. It can only change forms, and it is gonna stay in a closed system. So what does it mean? Let's give some examples here. I think it's going to be clear when we give examples. For example, you have electrical energy. You turn it to light energy. It goes from one form to another. We have chemical energy in the food. You eat the food and then you turn it into kinetic energy. The light energy comes from the sun, and plants use it. Plants use the photons and they do photosynthesis and they produce chemical energy. So they only change form. The second law of thermodynamics says it's about the quality of energy. It says you can transfer energy, you can change the energy from one form to other, but the more you transfer, the more it is wasted. So it says, the second law says there is a natural tendency of any isolated system to generate into more disordered state. Disorder means entropy. Entropy means disorder. If you have a solid ice, it has less entropy. If it melts and becomes liquid, it has more entropy. And if it evaporates, turns into gas, it has even more entropy than liquid form. And in nature, nature goes to more entropy. It goes to disorder. Okay, naturally, everything will be decomposes, and it creates more disorder. That is the nature of environment. So these are the two laws that explains the relationship between energy and our environment. The first one says energy can be transformed from one form to another. And the second law says when you transform the energy, you are going to generate more waste. You cannot keep it at 100%. There will be always waste. Remember that, for example, you are converting electrical energy into light energy, And when you touch the lamp, you will feel the heat, right? So are you going to use that heat? No, it's just wasted. That is second law of thermodynamics. You are transforming electrical energy to light energy, and heat is wasted there. And they explain the flow of energy in nature. The sun energy comes as a light, also as a heat. But the plants only use the light energy. So the heat is wasted here, heat lost here. The animals eat the plants, but to eat it, they waste the chemical, they take the chemical energy, but they use mechanical energy to get the food. So energy is wasted there. These preys trying to catch this food, right? And when they are trying to catch the food, they move around, they run off after them, they waste energy to get this energy. So that is related to second law of thermodynamics. Now I have a question for you. We have a prey, lion, and lion are running after the gazelle. And who are they gonna eat first? So you may watch this one in the documentaries, and you see they are chasing the gazelles. Who are they gonna eat first? They are gonna eat the weak ones, right? The weak ones, the sick ones, young ones, or very old ones. Why? Why are they doing that? Like, because they do not want to expend more energy in chasing the prey that it gets from the prey, right? So the predator here wants to use less energy because it doesn't want to spend more energy than it's gonna get from the prey. And that is explained by EROI. It is energy return on investment. And I think that is the very important topic for the future. And because all sustainability is related to this one. We will discuss with more examples. So let's define this one. EROI means energy return on investment. Let's make them capital. Energy return on investment. You are investing an energy for an activity, and this activity delivers an energy for you. And what we want for this activity, you want to put less energy, but you want to gain more, right? So you can have high EROI. So ideally what we want EROI way greater than 1. For example, you spend 1 kilocalorie of energy, you need to gain like 10, 100, 1000 kilocalorie energy. So your EROI will be 10 here. If you gain, that is your gain energy from the activity. That's what you gain from the activity, and that is what you spend, what you invest. Okay, what you invest. And that is what's your return according to this one. Your return should be way larger than what you invest, so you can have extra energy. And this EROI rules the environment, everything. For example, Joe the fish, that's an example. The name of the fish is Joe, and what happens to this fish? It eats, right? It gets the energy, and it gets the energy. Where does this energy used? It used for maintenance, right? And it used for growth. And if there is any extra left, he's gonna store it in his body. And even there is an extra energy, it is going to be used for reproduction. It is going to be used for movement, right? That is where we use the energy. And that example is the same for everybody. First, you maintain your body, you maintain the minimum energy. Then if there is extra, you will start growing, storing it. Imagine how you start gaining weight if you eat more calorie than you need. And then if there is any extra, then the population will grow. So that is the same rule for development of cities. Imagine when a disaster hit a city, they will first use their energy to maintain the city, right? If they have any extra energy, then they are going to use it for the development. If they don't have any extra energy, they will just stay as a disorder state. Disorder state means more entropy, more disorder, more chaotic environment. I'm going to give one more example, then I will stop here. That is the most important part of this environmental problems maybe, and it is the same for all sort of energies. For example, this is a fossil fuel. This is oil, and when it is first discovered, imagine it has 100 million joules of energy, as it is, without touching it. It's there. But to be useful for human beings, you need to extract it, right? You need to make a mechanism, and to build that mechanism, you use human beings, you use technology, you travel there, and you put some energy for this extraction. So you use 10 million joules of energy to extract the oil. So what is your EROI here? You have 90 left, right? 90 million left. You will get 90 million of it because you are putting 10 million joules of energy. That is your energy return on investment. Your investment is this, your return is this. Okay, you are going to extract it. Now you need to refine them. You cannot use it as it is. There are lots of impurities in it. You need to refine them. Yeah, then you need to put this into barrels. You are going to invent more energy, right? And your return will be less now. Then you need to transport it because we need it all over the world. For transportation, you invest more energy. And then you are going to use this for infrastructure. You need infrastructure for transportation. You need to build trucks, you need to build roads. You need even more energy. You need to put more energy to get the final energy. So imagine you start with 100 million joules, you invested a lot of energies in it, you end up getting only 20.5 million joules of oil. So that is a problem here. That's the problem in the fossil fuels now. So that is why we need renewable energies, because the energy return on investment is getting less and less and less every day. And that is a big problem for environmental science. I'm going to stop here and we will continue the next part tomorrow. Bye everyone.